Lesson 4.4 on triangle congruency. Now, let's talk about congruent triangles. Now, we've reviewed this from Chapter 1. Any congruent geometric object, including triangles, are two triangles whose sides and angles are all congruent. And thus far, the definition of congruency depended on knowing that all the angles in a triangle were congruent and all the sides in a triangle were congruent. But now in today's lesson, we're going to find some shortcuts to prove whether or not triangles are indeed congruent. To start off, let's try an experiment. Now, you've done this numerous times in homework from previous lessons, but again, just for a quick review, let's say you're given three segments to a triangle and you're asked to construct a triangle from these three segments. How many unique triangles can you actually construct when given these three sides? Well, we'll start with the longest side there. We'll just call it AB, and we'll construct out the other two side lengths there by measuring them with a compass and pivoting on both endpoints A and B. Find the point of intersection there, and where the point where those two arcs cross, we'll label as, say, point C. Once we have all 3 points defined in a triangle, we can just connect the dots, and we have exactly one unique triangle that can be constructed. You might say for a second, well, what about the triangle that you can construct below segment AB? Well, understand that it's the same triangle just reflected across the segment AB. So therefore, we can draw a conclusion from this construction experiment, and we call that conclusion the SSS, or side-side-side congruency conjecture, which says that if any three sides of one triangle are congruent to three sides of another triangle, then those triangles must be congruent. Likewise, let's say we did the same construction experiment, but instead of using three segments, we used two segments and an included angle. How many triangles can we construct that are unique when given these three components? Well, let's start out by actually constructing segment AB again, and then constructing angle A onto segment AB there, making the necessary construction marks. There we've constructed angle A, and then measuring out length AC, and actually plotting the length AC along that side there, and we've suddenly defined our third point to the triangle, point C. Again, connecting the dots, we have ourselves one unique triangle. This leads us to the following conjecture, called the SAS, or side-angle-side congruency conjecture, which says that if any two sides and the included angle of one triangle are congruent to two sides and the included angle of the second triangle, then the triangles are congruent. One quick note, when I say included angle, that means that the angle must be positioned between the two congruent sides. The angle cannot be outside the two congruent sides. It must be positioned within the two congruent sides. That is known as the included angle. Likewise, the ASA, or angle-side angle congruency conjecture. While you've done this construction in your homework as well, we'll just forego it right now and just get right to the point. The ASA congruency conjecture says that if any two angles and the included side of a triangle are congruent to two angles and the included side of a second triangle, then the triangles are congruent. Now make careful note again, the included side has to be the side between the two congruent angles and not a side outside the two congruent angles. Now, congruency order is important. Let's say that we're given these two congruent triangles, and we're supposed to create a congruency statement that shows that the two triangles are congruent. How do we list the points for the two triangles? Let's say that I list the first triangle as triangle ABC. Well, how do we list the order of the points in the second triangle? Is it DEF? Is it FED? Is it EDF? Congruency order requires that if we list the first triangle's points as ABC, then the second triangle in the congruency statement must have the points listed in the same order of the congruent parts. In other words, which angle is congruent to angle A? Well, in this case, angle F. Which angle is congruent to angle B? Angle E, angle C, to angle D. So, if we were to create a congruency statement that said triangle ABC, is congruent to, we have to say triangle FED, because that is the order in which both triangles have their congruent parts. This concludes today's lesson.